Now let's talk about what is Kirchoff's second law. So Kirchoff's second law deals with the voltage in the circuit. And the voltage in the circuit means the EMF and the PD lah. Now we have already explored a little bit when I was teaching you what is the difference between EMF and PD and potential. So remember the EMF is at the cell, PD is at the resistors, right now? And due to conservation of energy, I explained to you that the EMF must be equal to sum of PD. Because whatever energy that the current gets at the cell, it will be lost at each resistor, and then when it comes back to your cell, it starts all over again. So whatever energy gains here is lost here, then it start all over again. Understand now? So this is called Kirchoff's second law. The sum of EMFs around a circuit loop is equal to the sum of PDs around the loop. So I give you another example, right? We make it more complicated. Okay. So this is one loop and then another loop. Alright. So how many loops do you see here? 2. I can see 3. Because this is one loop, this is another loop, and this big one is another loop. Can you see that? So in each of these loops, the net EMF is equals to sum of PD, or the sum of EMF equals sum of PD. So I teach you how to write it down. For example, let's give this V1, V2, and V3, and this is the EMF. Now, how to identify the loops? Usually we will label the junction so we can identify the loops. So let's call it A, B, C, D, E, F. Now, if you want to use a particular loop, so let's say I say loop A, B, E, F, A. So A to B to E to F to A. Isn't it this loop? So that's how I identify the loop. And I will also mention which direction I want to read the loop. I can read the loop clockwise, I can read the loop anti-clockwise. It does not matter which direction your current flows. That means if your current actually flows this way, it doesn't mean that you must read the loop in this way as well. That means you don't have to read the loop clockwise, you can read it anti-clockwise, you get exactly the same answer. Okay? So but when you do Kirchoff's second law, you identify the loop, and you identify which way you want to read the loop, which is either clockwise or anti-clockwise. Now let's say I choose to read clockwise. Now how do I use these rules for EMF and rules for PD? Because when we say the sum of EMF equals sum of PD, there are some rules to follow. You cannot just add up everything. Sometimes your EMF can be positive and negative, sometimes your PD can be positive and negative. So for EMF, what is the rule? The rule for EMF is positive when direction of travel is equal to direction of EMF. So what does it mean? Now, every cell has a direction of EMF, which is the direction it wants to push the current out. So the direction that this cell wants to push the current out is here right now. So this is called direction of EMF. So if the direction of EMF, this way, is equal to direction of travel, so what do you mean by travel? See, can you see I'm moving A, B, F, A, which is clockwise? So I'm reading this way, that means I'm traveling this way, that means I'm moving up from F to A, and the EMF also same direction, right now? Then this value of EMF I will record as positive. But if let's say I read the loop anti-clockwise, A, F, E, B, A, if I read anti-clockwise, then my direction of travel, which is from A to F, is opposite to my EMF right now. Then the EMF will be negative. That's how you must read it. Okay now. Now what about PD? PD also has positive and negative. So for example, it says that PD is positive if the direction of travel is equal to the direction of current through the resistor. PD is negative if direction of travel is opposite direction of current through resistor. Now, let me just write first. Since I already said loop A, B, E, F, A, which is this way, and my travel is same direction as the EMF, so my EMF is actually positive. So I call it positive E. Understand? Equals to, now, the PD, if I'm moving this way, I must look at the current. That means I must find the PD here and the PD here. In other words, in this loop, can you see there are two resistors? So with this PD and this PD right now. So what is the PD here? My travel is this way, A to B to E to F to A. That means I'm traveling this way. And the current through this resistor is also to the right. Can you see that? So same direction, so the PD is positive. So it's positive V1. And if let's say I travel down here, so I'm moving down. The current through this resistor is also down, so it's a positive PD. So it's plus V2. I show you the difference if I read anti-clockwise. Let's say I read loop A, F, E, B, A. That means I'm traveling anti-clockwise this way. So if I'm traveling anti-clockwise, I'm traveling this way, but EMF is opposite, so therefore it is negative E. When I reach these two resistors, so let's say I come to this resistor, I'm traveling here to the left from B to A, but the current is from A to B. So it's a negative PD, so it's equals to negative V1. And if I look at this resistor, if I'm traveling this way from E to B, but the current is downwards, so it's a negative PD, so it's minus V2. But if you think about this, right, isn't this the same as this? So therefore, regardless of how you read the loop, whether clockwise or anti-clockwise, you end up with the same answer. But you must follow the rules when you're reading. Okay? Alright.